Okay, geometers, here we go for the Locus of Points notes. This is day 1 of Locus of Points. And to get us started off, you need to put your name and today's date on your paper. And here we go. So we have a few definitions at the beginning. Locus, so we need to star squiggle this, is the set of all points that satisfy some given conditions. Squiggle that. That's important to have that concept of what that is. And you could think of a locus of point, there's a couple of items here. Think of a locus of points as a bunch of points that do the same thing. It's a Latin word that means place, and the plural of locus is loci. There's one for your vocabulary. And here I have something that we have starred 3 times, which means when you're drawing your diagram, which yes, we will be drawing some diagrams and making some conclusion about it, that the original conditions are always done in solid lines, and the locus of points is always done in dashed lines. And that's the way you can distinguish what you started off with and what you end up with. What are those locus of points that fit that description? So there's 5 basic theorems that we have to remember when we're dealing with locus of points, and here they are. So the first theorem says that the locus of points that are equidistant D from a point P, which is xy, and that would be our given, is a circle. And we can describe that circle as having a center xy with a radius of d. So that's the first one. The locus of points about a point gives us a circle. Theorem number 2 says the locus of points that are equidistant d from a line L is 2 parallel lines, which means they have the same slope, one on each side of line L and a distance d apart. So that's theorem number 2. We'll star squiggle that, and there's some nice diagrams that were given, and the diagrams, well, probably on your paper it's not blue and red, but the blue is the original and the red is the locus of points, and notice that they are dashed lines. Theorem number 3 says that the locus of points equidistant between 2 points, point P and Q, is the perpendicular bisector of the segment created by point P and Q. That's number 3. And over here we have the diagram as well with the perpendicular bisector. And remember, all those vocabulary terminology, the midpoint, how do I know if it's perpendicular, what's the relationship about their slopes, so forth and so on. Theorem number 4 says the locus of points that is equidistant between 2 parallel lines is a single line parallel to the 2 given lines midway between. So we could also on that one talk about distance d between the 2, or show somehow that the distance between the 2 original lines and the parallel line is the same distance by labeling it or marking it with our congruence markers. And then theorem number 5 says the locus of points equidistance between 2 intersecting lines is the angle bisector of the angles formed by the original intersecting lines. And here's a note here on this one also, that those loci will be perpendicular to each other. The loci, which would be the 2 perpendicular bisectors, will be, sorry, the 2 angle bisectors will be perpendicular. Okay, so let me just give us a little more space here. So those are the 5 rules that we need to remember. And we're going to do examples of those 5, so let's go to the next page. And here, first we have to talk about how do we solve the problem. So first we need to describe. We need to describe. That means, yes, you have to use some words to describe what is created when the specific conditions are met. So if it's a line, you could write the equation, or you could describe the line. If it's a circle, you describe its center and its radius. If you had enough information, you could even provide the actual equation of the circle if you had enough information. So here's the general steps for solving the problem. You draw a diagram first showing what you're given, whether it's a point or a line or 2 points, and then you carefully read what the conditions are that must be met. So it has to be equidistant, or they'll give you some kind of description about how far away it is or something like that. And then on your diagram, you need to locate several points that satisfy the condition, and then plot them on your diagram. And once you plot enough of those points that have that condition, you will see a pattern of the dots or the dashes that you're putting on your paper that will create a circle or create a line or something like that. So number 4 says, through these plotted points, draw a dotted line to indicate the locus or the path of these points. And from if you noticed on our description of the theorems there 1 through 5, it's either going to be a circle, or it's going to be 2 parallel lines, or it's going to be, and right now I want you to look back on that other page and I want you to fill in the other 3 possibilities that it could be. So really there's only 5 things, the basic locus of points you are responsible for. It's either going to be one of those 5 things or a combination of those. And then number 5, once you get your picture drawn with those dashed lines, you're going to describe it in the geometric path that you see. So, we have to use our words. Is it a circle? Is it a line? Is it a parallelogram? Is it 2 points? Something like that. And then number 6 comes in. It says if 2 conditions exist in the problem, which we call a compound locus, you just keep repeating the steps for each of the conditions on the same graph, and then you're going to be telling me where they intersect. So this right here, number 6, actually is day 2 when we talk about compound loci. So here's a little hint down here. Things that could be represented as points, sometimes they talk about a shrub, sometimes they talk about a tree, a telephone pole, a house, or anything else that could be considered a point. Lines could be a road or a fence or something like that. Intersecting lines could be 2 roads, 2 fences, something like that. All right, so now we're going to get on to some examples, some problems. So number 1, these practice problems, says find the locus of points that are 5 units from point P. Well, point P is what we are given. So we're going to draw our original picture just with a point P. And then we need to locate points that are 5 units from it. Well, if you noticed, if you had a point, you could have 5 units. Could be up here, or it could be down here, it could be over here, it could be over here, it could be here. And if you notice these points, when we look at them, they do kind of make up a circle. And notice that it's dashed, and this is a freehand circle, and it's not very good, but of course if you had a compass, you would use it. So here is our point P, and we have no graph paper, so we're just going to say that it is 5 units away. So how would you describe that? The locus of points would be a circle with center P, and we know that the radius is 5. Okay. On to example number 2. Describe the locus of points that are equidistant from line G. So again, here our given is line G. So we need to draw ourselves a picture of our given situation. Here's line G, and we're just going to label it. Notice these are just sketches. There's no graph paper, so we can have our own distances or whatever. Okay, locus of points equidistant from line G. Well, if we had this line G, and we needed something that would represent the points that are equidistant from it, well, we would have one line on that side that would be a constant distance away, and we would have another line on this side the same distance away, and we could mark that by, if we showed our distance here, put D to show that they have the same description, D. So if we had to describe that locus of point, we would say 2 parallel lines, a distance D on both sides of line G. Of line G. Okay. On to number 3. So these really aren't that hard. You just have to come up with a picture and be imaginative about where the dashed or the dotted lines would go, or the points. So next we need to draw the locus of points that is equidistant between 2 points, A and B. So again, here's our given. We have 2 points that we need to start off with. Here is point A, and we'll have point B over here. And so if you, the first initial spot that you would pick, would be right here in the middle of AB. But if you remember, if I looked at this as a segment, that's going to be the midpoint, so we could label that midpoint. But if I had a point here, it too would be equidistant from point AB, and then down this way, the same thing. So if you look at that, we've actually created this line between segment AB that would be perpendicular. And because we know it's at the midpoint, it's going to bisect segment AB. So our description of that locus of points would be a perpendicular bisector of AB, and we can just write it with our segment notation, AB, that goes through the midpoint. And of course, if we had the ordered pairs for point A and point B, we could actually calculate the midpoint. We could also actually come up with the equation of that line if we had enough information. On number 4, find the locus of points that are equidistant between 2 parallel lines L and M. That's our given. So we're going to draw our picture for that. Here's 2 parallel lines. This is going to be line L. This will be line M. And again, the first, if it's equidistant between, it's going to go right down the middle of these 2 parallel lines. It too will be a line, so we need to label that with arrows at both ends. And it's going to be in the middle, so we need to show that our distances between are the same, so we'll label them D for distance. And we had to come up with a description, which would be a line parallel to L and M at a distance D from both lines. Now you could also say through the middle, or however you would like to describe it, as equidistant between those two. Okay, and the last example is draw the locus of points that are equidistant between 2 intersecting lines F and G. Intersecting lines F and G is our given. So this is going to be my line F. Label that here. This is going to be my line G. Label that there. Put our arrows on. And so we know that if we looked at points that were equidistant between those 2 lines, if we just looked at this segment, and we know that we already have intersecting lines, so we know that we get these vertical angles that are congruent, and these 2 angles would also be congruent. So we're going to mark those right now. And so if you took a point that was equidistant between F and G on these 2 sides, it would actually bisect that angle. So that would be an angle bisector. And on this side, you would also get the angle bisector of those 2 angles. And so to describe those, you would get 2 angle bisectors. And that's it. Okay, so that concludes our video for Locus of Points 1. Next video, we'll do a little recap, and then we'll talk about compound loci. Okay, all done. See you in class tomorrow.